So first of all, I'll give an introduction to what we are calling the Reverb Object. And I guess the starting point is a basic point about physically what is reverberation. So if we have a sound source and a receiver, a microphone in a room, in terms of the impulse response, we first get this direct sound, and then we get a collection of initially sparse, but then increasingly dense temporally, early reflections that are telling us information about the scattering absorption from those reflectors, the walls and floor and ceiling, which eventually become so dense that we have a kind of diffuse sound field. So that's the kind of physical phenomenon of rooms, but we're listener-centered in our perspective here, and so taking a perceptual view of the impact of these things has some greater relevance in a way. So we want to think about the direct part as the thing that takes precedence and signals the direction of the source. And from the early reflections, we get information about room dimensions. The early reflections can enhance the kind of loudness, clarity, and colour. And the late reverberation gives us this sense of envelopment, and also is a very important cue to the distance of a particular sound source within the environment. So because of this, reverb is an extremely versatile effect in sound design, and it's used universally in sound reproduction to create these impressions that are so important. Of course, we also want to get on the bandwagon of object-based audio in the context of this project, and so there are opportunities that one can exploit if we have a reverb object, both to customize and personalize the thing that we are listening to in the similar kind of way. So I guess I just want to remind ourselves about this pipeline. So from recording and objectification, we then get to master and transmit the information that's rendered for the listener. And so if we're, and maybe personalized. And so if we have a kind of recording of some performance at one end, what we're seeking to do in general is to enable that to be transmitted to the, into the minds of the listeners. And here what we're interested in doing is also taking the information about the acoustic environment and making sure that that becomes part of the impression that they receive at the listening end. But one of the problems is that in the standard object concepts, and I'm talking specifically about audio objects here, we had a kind of toolbox or a palette of sounds that covered some standard ideas. So we had a point source, a plane wave source. There's also the idea of a source with some width or height with extent defined in the standards, and a diffuse source similar to the characteristics that Mike was describing earlier. And so the problem is, well, what is a reverberated source in this context? And so to begin to unpack that, we first had a look at the literature on spatial reverb, and we could kind of unpack the main ideas here into some groups. So at the top, we have methods that kind of make a model of a room and then use some computational network to produce the audio. Whereas on the bottom, we have a set of methods that are based on measured impulse responses of a room. And then the differences can be most apparent in this middle part, where you're trying to work with it in a creative production process. So the top level ones have the advantage that they're quite high level editable parameters, but the bottom ones, but they may be difficult to deduce from a room, whereas the bottom ones have a better kind of accuracy in the representation, but a representation that's very difficult to work with. And so we were seeking to occupy this sweet spot in the middle of something, a sparse representation that's nevertheless based on real rooms. Okay, I won't go into the details, but in essence, we've separately encoded the early part in one way and the late part in another way to do that. And then we've kind of constructed the components we need to be able to get this entire pipeline working for the reverb object. So On the capture side, we've looked at extracting dialogue objects, and these are some of the talks that immediately follow. Extracting from the acoustics, the characteristics that we encode in metadata, or from the visual. We then have production tools that enable us to attach this to a dry object track and represent it within the plugins. And then we can render this using our point source with Reverb object type. And we've performed subjective evaluations on this as well. Okay, so Reverb carries important properties, but it's complicated. We've used perceptual kind of sparsification to get to the core of it so that we can customize and personalize. And then recognizing that the standards didn't cover what we needed, we looked to see what spatial reverbs can do, and then proposed our end-to-end reverb pipeline to create, to capture, create, master, transmit, render, and evaluate the result.